Good afternoon, my YouTube viewers. It is Crystal here. It's been a while since I have made a video because I've been really busy doing other things. But what I wanted to do in this video is I wanted to create an A/B tester in Excel. And so basically what I'm going to do now, and this is written in Visual Basic, Excel's Visual Basic. But what I'm going to do now is I'm going to clear the contents. And then now what we're going to do is we're going to do an A/B test in Visual Basic with a program that I've written. So we're going to click on to test A/B. Brief description of Group A. So we're going to say a website with green coloring. That's your description of Group A. And then we're going to do for Group B, we're going to do website with blue coloring. So now we're going to say enter instances of Group A. So there's going to be 1,000 instances. And we're going to say enter instances of Group B. There's going to be 1,000 instances. And then enter successes in Group A. We'll say 120. And enter successes in Group B. We'll say 200. So then we're going to do enter the significance level, which is your alpha. So it's going to be 0.05 is your significance level. And that's the end of your program. And then so basically, you're going to fail to reject the null hypothesis because you had a conversion rate for Group A for 12%. Conversion rate for Group B for 20%. And then the pooled conversion rate is 16%. Standard error is 0.66. Z-score is negative 0.12. P-value is 0.9, which is high, which means it's going to be failed to reject the null hypothesis. And then the alpha is going to be a 0.5, which is your significance level. And a null hypothesis is no significant difference. And alternate hypothesis is a significant difference. So this is what we've come up with. But what I'm going to do is I'm going to do another A/B test. I'm going to do another one. Say green. Green color on site for A. Blue color on site for B. Instances on A. Instances on B. Successes on A, I'm going to say 50. Successes on B, I'm going to say 200. Significance level is 0.05. It still says failed to reject the null hypothesis. I don't know how they came up with that because the conversion rate is 5% on the first one and the conversion rate is 20% in the second one. And then you have a p-value of 0.819. But what we'll do is we're going to actually look at the program in Visual Basic. So this is the program. So what we have to do is we have to declare or define all of our variables. So the variable is going to be Group A, describe, Group B, describe, instance A, instance B, success A, success B, conversion A, conversion B, pooled rate, standard error, z-score, p-value, alpha, and interpretation. So group A equals describe in box, enter a brief description of group A. And then group B described as the same thing. And then cells 2, 8 is a group A plus group A describe. And cells 3, 8 dot value equals group B plus group B describe. Cells 1, 1 is group. Cells 1, 2 is instances. Cells 1, 3 is successes. Cells 1, 4 is conversion rate. Cells 2, 1 is A. 3, 1 is B. So, and now we do instances A equals inbox enter value of instances in group A, and instances B is exactly the same thing. So cells 2.2 dot value equals instance A. Cells 3, 3 dot value is instance B. So success A equals input, enter number of successes in group A. Success B is the same except it's success B. Conversion A equals success A divided by instance B. And conversion B equals success B divided by instance B. Cells 2, 4 dot value equals conversion A. Cells 3, 4 dot value equals conversion B. And then cell 4, 3 dot value equals pulled conversion rate P. Pulled rate equals success A plus success B divided by instance A plus instance B. Cells 4, 4 dot value is pulled rate. Cells 5, 3 is dot value is your standard error, SE. Standard error equals pulled rate times 1 minus pulled rate times 1 divided by instance A plus 1 divided by instance B. Cells 5, 4 dot value equals standard error. Cell 6, 3 dot value equals z-score. Z-score equals conversion A minus conversion B divided by standard error. Cell 6, 4 dot value equals z-score. Cell 7, 3 dot value equals p-value. P-value equals worksheet function dot norm s dis brackets negative abs brackets z-score comma true times 2, and cell 7, 4 dot value equals p-value. And then cells dot 8, 3 dot value equals alpha. Alpha equals inbox. Enter the significance level, normally 0.05. And cells 8, 4 dot value equals alpha. Cells 10, 3 dot value equals interpretation. So if p-value is less than alpha, then interpretation equals reject null hypothesis. Else, interpretation equals fail to reject null hypothesis. End if. So cells 10, 4 dot value equals interpretation. Message box end of program end sub. So that's basically the code that we're using to do this. And so since the p-value is greater than the alpha, you're going to fail to reject the null hypothesis. But let's see what we've got. I don't understand why an instance of success with 50 and instance of success of 200 is going to give you a p-value of 0.8191. But let's just try this one more time. See what happens. So that's your green color and your blue color site for group A and B. Group A, you have 1,000 instances. Group B, you have 1,000 instances. Success in group A, we're going to say 50. Success in group B, we're going to say 500. And then significance level is 0.05, that's 5%. End of program. And it still says fail to reject null hypothesis. So, I mean, how high does it have to go to reject the null hypothesis? So, that's something I'm going to have to look into, because how much difference? Because I would say that there would be a significant difference between 50 and 500, and you only have a p-value of 0.05. So let's try this one more time. The first one is going to be green, but I may have said blue because I'm a little bit concerned about this p-value. 1,000 group A, 1,000 group B, success in group A, and success in group B, we're going to say 750, and 0.05, end of program. And it still gives you a p-value of 0.3, so I'm not too happy about that. If p-value is less than alpha, then reject null hypothesis. Otherwise, fail to reject the null hypothesis. And then we've got the worksheet function equals abs score, comma, true times 2. And so there's definitely something wrong here, which means I'm going to have to look at the code a little bit more, because I've got the code here. And so I'm going to say here for your p-value, I'm going to put that there. Dot 2 minus 1 minus norm dot des over z-score true, say, times 2. One minus norm dot dis. Let's see what happens. But it's not, it's saying 1 minus norm dot dis. ABSC score, comma, true, times 2. And so it's not letting me do it that way. It says norm.s.dist, and it won't let me do 1 minus norm.s.dist. So there's definitely a problem here. And I'll have to figure out what the problem is, because let's try this. I'm going to say 100 and 100. And then we're going to say 0.05. So it doesn't matter what happens. It says your p-value is 1. So that's going to definitely fail to reject the null hypothesis. So let's try and we're going to say 100, and then we're going to say 900. And it just says it still gives you a high alpha. It doesn't matter what you do. It gives you a high alpha. So let's try it again. So we're going to say 10,000 and 10,000. And then we're going to say for green, it's going to be 150. And for blue, it's going to be 5,000. So it's still not working. It's still 150 to 5,000. So it's still not working. So there's definitely a problem here that I'm going to have to look into. And I was going to actually let my boyfriend sell this as a digital product to help him out with his business. But I've got to try to find out what the problem is before it's sellable. So thank you so much for watching my video. At least we found out that this A/B test isn't really working the way we would like it to work. But when I get it working, when I get it sorted out, I'll definitely make another video and let you know.